Okay, so we're going to try and make sense of those tSNE results that we were getting. As we saw, it was showing 4 clusters, but what do those clusters represent? And as with the k-means, fundamentally, what we understand is why the data is clustered together. Why are those data points considered similar to each other by the algorithms? One way of doing that manually, it is very manual, but one way of doing that is to pick a group of data points using a simple rule. So, for example, high volume or low ratings. So, if we were looking at products, the product sales, we could look at high volume, or in this case, we've got ratings, which are too difficult to understand. So let's pick the low ratings or the high ratings and use that group to test out whether those data points stay close together in the different tSNE plots. So having identified a group of data points like that, we'll split the data set into 2 subsets, our group that we've selected and all the others. And then we create a number of different tSNE embeddings using different perplexities and plot all the group data in a different color. So we plot our group in a different color to all the others. And if our group consistently matches a tSNE cluster of all those different perplexities, then we know what rule is generating that group. So we've decided, say, low ratings. If those low ratings are consistently clustered close together in all the tSNE plots, then probably that cluster is being generated because tSNE considers that products with low ratings are similar to each other. Okay, so let's try with low ratings. So we can look back at the bar chart that I showed you a few slides ago and see that low-rated products are these K, E, A, E, G, J, and X. Without looking at, at the code in detail, this is similar to the previous example, but using 2 groups. Okay, so I'm plotting the same data set, but I'm now doing 2 scatter plots on the same chart to give 2 different colors. Low-rated products will be plotted in blue and the others will be in orange. And I'm going to try those useful perplexities, the ones that I identified earlier that were giving us useful results. So 6, 8, 10, and 12. And that's what happens when I do that. Okay, so I know that the blue products here and here and here and here are the low-rated products. And tSNE has identified them as being in the same cluster. So one of these clusters that tSNE identifies consistently has all the low-rated products in it. Okay. Remember, the absolute positions don't mean anything, but that's telling us that tSNE is identifying low-rated products as being similar to each other in some way. Well, that's good. That's a good start. Let's try high ratings. So let's do the same technique, but with high ratings. Okay, so the high-rated products are LH, S, T, and D. So going back to that bar chart that I showed you. So again, I'm going to show those in blue, and I'll show the others in orange, and we'll use the same perplexities. And again, I get all the high-rated products here, 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 and here. They're all shown close together in the tSNE embeddings. So another of those tSNE clusters represents high-rated products. Okay. I should warn you. Notice when I do this, I get different positions for all the data points. Okay, that's unfortunately a consequence of tSNE. It's a randomized algorithm, so you don't get the same results every time. And because I'm putting because I'm putting the data in different order, I get a different set of results, even if I try and fix the random seeds, if you know what I mean by random seeds. So we can't take the positions, as I say, can't take the positions to mean anything, but we can see now that one of those tSNE clusters is consistently showing the high-rated products and another one is showing the low-rated products. So maybe that's enough. Maybe we can just use the ratings to differentiate our projects into 4 different clusters. So let's try it and take the low-mid ratings. So These are products that are low rated, but they're mid rated, but they're lower half of the middle. Okay, so going back to example 2, it's the sort of the second quartile of the bar chart. We'll show them in blue and we'll show the others in orange and use the same perplexities. Okay, but now it hasn't worked. So if I take those low rated products, the blue ones, they get split up. So some of them get put over here in this cluster and some of them get put over here in this cluster. Same for perplexity 8, some of them are in this cluster, some in that one. Same for 10 and 12. Obviously, whatever these clusters represent, this one and this one, it's not low mid-rated products. Okay, we know that one cluster is low-rated products and one cluster is high-rated products, but whatever these ones are, it's not low mid. So it doesn't work to interpret the other two clusters. And the same, you'll find the same if you did it with high mid rated. It'll give you the same problem. They'll be the orange ones in these two clusters will be the high and mid rated. So they're mixed up, these two clusters. Okay, so let's try using k-means clustering and then look at the tSNE embedding. So I'm going to finish that video there, and then we're going to do this in a different way. So that was a kind of manual clustering where we pick a manual cluster. Now in the next video we'll do k-means clustering and use tSNE.